Hello again and welcome to the second part of my videos on model evaluation, specifically on classifier evaluation. In the last video, we introduced the confusion matrix. We introduced several metrics that we can extract from the confusion matrix, and we mentioned that we will only be concerned about binary classifications, and we said that any multi-class classification problem can be seen as or can be viewed as a binary classification problems. Please go back to the previous video if you want to understand how these things work. Now, we said this is what the confusion matrix looks like. Again, it's for a binary classification problem. So we have a positive and negative classes, two classes. These can be positive 1, minus 1, yes or no, true or false. It depends on your purposes. And we mentioned that we have the matrix built as follows. We have the target or the actual classes of our instances, and here we have the, the predictions of our model. So this is the number of actually positive classes which were correctly predicted to be positive. This is the number of actually negative classes which were predicted to be positive, incorrectly of course by the model, and these are the actually positive classes which were incorrectly predicted to be negative by the model, and these are the actually negative classes which were correctly predicted to be negative. Here we're speaking about the numbers of instances, so these are counts of different instances. And we spoke about the precision and recall, how to compute these values from the confusion matrix. By the way, sometimes people build the confusion matrix the other way around, so they put the actual classes as rows and the predicted classes as columns, but I'm sure you understand the concept, so that shouldn't confuse you. Again, sensitivity, specificity, as we mentioned before, precision and recall, and all these kind of metrics, and the accuracy as well. Now we'll introduce some more. We'll introduce the number of true positives, the number of true negatives, the number of false positives, and the number of false negatives. After that, the true positive rate and the true negative rate. This small confusion matrix here is different than the one we saw before. Here we had the actual values or actual classes as the columns. Here we have the actual classes as the rows, so positive, negatives, and here these ones are for the model, predicted by the model, positive and negatives. Now the ones which are actually positive and predicted to be positive, that number is called the number of true positives. True positive, the name says it all, actually positive and predicted to be positive. Then the number of false negatives, however, is the ones which are actually positive but they were predicted to be negative incorrectly by the classifier. The number of false positives is the number of instances which are actually negative but they were incorrectly predicted to be positive by the classifier. Again, the name says it all, they are false positives, so they are predicted to be positive incorrectly. And then the number of true negatives is the number of instances which are actually negative and they were correctly predicted to be negative by the classifier. Now we can compute what is known as the accuracy on the positive class, or the true positive rate, which is the number of true positives, TP over or divided by the total number of positives, so TP over TP plus Fn, the true positives over the true positives plus the false negatives. This is known as accuracy on the positive class. Similarly, we can compute the accuracy on the negative class. But now we'll compute the true negative rate, which is the number of false positives divided by the total number of negatives. So the number of false positives divided by the number of false positives plus the number of true negatives. This is the same as 1 minus the accuracy on the negative class. So we mentioned that this is how we compute the accuracy of the positive class. Accuracy on the positive class. We can also compute the accuracy on the negative class in the same way, and then this value here, the true positive rate, is 1 minus accuracy on the negative class, or we can compute it as follows: number of false positive over number of false positive plus the true negatives. Now let's have a simple example. Today it's raining in London. Today is the 25th of July 2014. You expect the sun to be out, but this afternoon we had some quite heavy rain. It's unbelievable. Now, an example confusion matrix. Back now to the original format, which gives us um, the actual values or actual classes as columns and the predicted classes as rows. And these are the number of true positives. These are the number of um, false positives because they are actually negative, but they were predicted to be positive by the class. Likewise, the ones which are actually positive and predicted to be negative, so false negatives is 30, and the number of actually negative and predicted to be negative is 80. So the number of true negatives is 80. This is just an example, and then from these counts we can easily compute the metrics that we explained in this video and in the last video, or everything: accuracy, sensitivity, specificity, and precision, recall, as we mentioned, and the ones that we introduced in this video: true positive rate, true negative rate, accuracy and true positive, which is the same, or accuracy on I'm sorry, accuracy on positive class, accuracy on the negative class, and so on and so forth. I hope this makes sense. It's quite simple but really powerful in model uh, evaluation. Thanks very much for watching, and I'll see you in my next video.